Hello everybody. Today we will start with the next chapter in physics, that is chapter number 7 of standard 8th sound. So that is for ICSE 8 standard. Now first of all, sound is a kind of energy. Okay. Now we had studied that energy is that particular kind of a physical quantity which can do work. Okay, so and what is work is when some force can move a body by a distance. So we can see that even sound has the capacity to move an object, and that you can easily experience when you are playing a loud music. Then the glass which is kept on a table will start vibrating, or it is like uh, the speakers also, the sound of the what you can call the diaphragm, or the speakers के जो black color के जो speaker होते हैं, that also vibrates. So that vibrations, what you can see is nothing but the work done, because there is a movement taking place. So that's why we can consider that sound is a form of energy. So once it is a form of energy, it can be converted from one form to another form. So let's see in detail what exactly is sound and what are the different things we are going to learn about the things in sound. So we start with the chapter Introduction. In class 7, we have read that sound is a form of energy which produces a sensation of hearing in our ears. So yes, we normally define sound as that particular kind of a physical quantity which is going to give you a sensation of hearing. Okay, we are able to hear the birds cheep, we are able to hear some kind of a movement somewhere. तो या तो tapping of the table, ये सब कुछ हम लोग सुन सकते हैं. तो that particular move, that particular thing which is making us or enabling us to hear something or listen to something, which is nothing but the sound. So sound is produced when a body vibrates. Thus, each source of sound is a vibrating body. So the sound is going to be produced only and only if any particular thing is vibrating. The vibrations caused in any substance causes the sound to be formed. Okay, so sound is going to be produced due to vibrations. So the vibrations are the, you can say, the source of the sound. So that's why the sound will always be accompanied by some or other vibration. Like if I take a rubber band, rubber string लिया और उसके बाद उसको हिला, तो वो vibrations जो होगा, you can hear the sound of the vibrations of the rubber string. So that is all the example, or that's why we are giving this example over here. For example, take a rubber band and cut it into a string. Now stretch the string, keeping it one end in your mouth under the teeth and the other end in your hand, or as shown. So basically you are taking a rubber string, and why we are putting a teeth? Because you need to vibrate with your hand. But if you are doing this way and putting it this way, also so fine. Basically the rubber band should be in a form of a stretched string. Okay, if it is in a form of a stretched string, you can easily do this experiment. You will find that you will be able to get a sound from the rubber string. So when you plug the string from the middle, you see that the string starts vibrating and a feeble sound is heard. So when you do that thing, you will find that there is going to be, of course the vibrations will be there, and that vibrations ke saath mein, there will also be a feeble sound, a very soft sound of the vibrations of the string will be heard on plugging the rubber band at the center. Now, sound needs a medium for its propagation. Now, sound is a particular kind of energy which can travel only if there is a medium available to it. The medium could be air, water, any solid, anything. But if there is no medium, that means if there is vacuum or that is outer space, then we cannot hear anything, because the sound cannot travel if it is there in the vacuum or in space or where there is no medium. And that is the reason that very big explosions takes place in the in the solar system or maybe even outside, but those explosions are never heard on the Earth's surface because those explosions are taking place in the space where there is no medium, and accordingly, due to this particular thing, we do not hear any kind of those sounds which are taking place, or that particular explosions which are taking place in the space. So it cannot travel in vacuum. The sound needs a medium for its propagation, and it cannot travel in vacuum. This is why two persons cannot hear each other on the moon or in space where there is no atmosphere. So in the space or in the atmosphere, two people, if they are there, they will not be able to speak to each other, they will not be able to hear each other unless until they are in a particular closed atmosphere. So that's why in the spaceship, yeah, they are able to speak, because in the spaceship it is a controlled atmosphere where oxygen and everything is available in that particular spaceship. That's why there is a medium for the propagation of the sound. But if they go outside, then they will have to use the transmitters which are put inside that suit of theirs, which is going to transmit the sound from one person to another person. So they cannot directly say, even if somebody is knocking over there, you cannot hear the knocking because it doesn't have a, means if somebody say claps also, you will not be able to hear, because outside sound will not be heard, but something which is made inside the suit where the mic is located, and when there is space available or the air available, there of course the transmitter will be able to transmit it. So that's why we can see that in space, if two people are in space and they are trying to speak with each other, like suppose two people are on moon and they will not be able to hear each other because our sound cannot travel on moon or in the space. Sound can travel in solids, in liquids, as well as in gases. Its speed is more in solids, less in liquids, and still less in gases. The speed of sound in iron is nearly 5,000 meter per second. In water, it is nearly 1,500 meter per second, and in air, it is nearly 330 meters per second. So it can be seen that sound requires medium for its propagation. Sound requires a medium. Now, that medium, the denser the medium, okay, the denser the medium, the closely packed are the particles of the medium, the more will be the speed of the sound. So that's why if the speed of the sound is to be calculated in a solid, like for example, if I got a iron rod which is very long and I'm just tapping on one side and somebody is hearing it from the other side, so even if it is a 1 kilometer long thing, then also it could travel in just a second or so. Okay, that will be easier for it to reach that in just 1 second. Where if it even in water or in liquid, the speed is going to be slightly higher than what is there in air. So it is seen that the speed of light, speed of sound in air it is the lowest, that is only 330 meter per second. That means it can travel only 330 meters in 1 second, right? That is in air. But in case of water, it is almost equivalent to 1,500 meter per second, almost 5 times. And in case of iron, it will be as high as 5,000 meter per second. So you can see that almost there is 3 times, okay? Iska 3 times ye, iska 3 times ye, approximately. So that's why we see that more denser the material, more is the denser the material, if the density of the material is higher, then the sound can travel more faster. So denser the material, faster will be the travel of the sound in that particular medium. Hence we have that the speed of sound in iron is nearly 5,000, in water is 1,500, and in air is 330 meter per second. When a body vibrates, the particles of the medium also starts vibrating. So how does it travel? The travel of the sound is that, now we took the example of the string. So when the string is vibrating, the vibration of spring is taken up by the vibration of the air. So when the string vibrates, the air also starts vibrating, and the particles of the air will keep on vibrating. Means एक particle ने इसको दिया फिर इसने उसको दिया फिर ऐसे करके the particles are set into vibrations by the vibration of the particular source of sound. So accordingly, like even when I am speaking right now and you are sitting over there, so when I am recording this thing, so what is happening? My sound, which is coming out from the ear, the vibrations of the vocal cord is giving the sound. That sound is setting the vibrations in the air, and that air is traveling and reaching the speakers over there, a mic over there, which is absorbing the sound. So this is how the sound is going to travel from one person to another person. So that's why when a body vibrates, the particles of the medium also start vibrating. During vibration, the kinetic energy of particles change into potential energy, and the potential energy into kinetic energy. This is why sound is a form of energy. So what basically happens is, when it is set into motion, तो जो चीज steady at rest था, उसके पास potential energy था, it got converted to kinetic energy. The one which was in motion became again into rest, and that's why it got potential energy. So potential energy gets converted to kinetic energy gets converted to potential energy, and accordingly you can see, since this particular sound is getting converted into different form of energy, we say that sound is also a form of energy. And this is why sound is also a form of energy, because it is getting converted from sound energy to kinetic energy and potential energy. So always it will be sound getting converted to kinetic energy getting converted to potential energy again getting converted to kinetic energy, and so on. The movement goes on from the source to the listener. So let's see how the sound is going to travel, or propagation of sound in air. Now in air, the propagation of sound is going to be in a wave which is called as longitudinal waves. Okay, so the type of waves which are going to be there in case of air are called as longitudinal waves. Okay, so when a source of sound vibrates, it creates a periodic disturbance in the medium near it. The condition of the medium changes, that is, the condition of medium changes. The disturbances then travels in the medium in the form of waves. This can be understood by the following experiment. So what we do over here is a small experiment, wherein what we'll do is, suppose I have got this particular scale. Okay, now when the scale is just placed over here, so the scale is like this, you will find that the particles of the air are very well distributed, and they are going to be like this. It will be equidistant shape. They are going to be placed in this particular manner. So this is how the waves of the air would be there when there is no disturbance. So here there is no disturbance because this is just steady. Okay, these are the different particles. We are just assuming that these are the particles. Okay, it is something like a cycle stand है. Cycle stand पे सब line में cycle पड़ी है. Okay, if I push one of the cycle, what happens to the other cycles? They are also going to fall one upon the other, right? Something like that. But here it is not exactly like that. Here what is going to happen is, if I take this particular string, it's a scale, and I am going to put it into vibration. So what is happening? It is going to go this way, this way, this way. ऐसे हो रहा है. तो जब ये it is moving in forward direction, this forward direction movement will push these particles a bit. So what will happen is, this, when it is going to come in this position, that is like this, it is pressed this way, the particles over here, the front particles over here, that is these particles over here, they are going to compress. So they are going to compress like this. Okay, they are going to compress like this, and then after that there will be again, there is no change. So this one is the first change, that there is going to be some particles are going to get compressed. तो जो पहले था, तो यहाँ पे जो पार्टिकल था उसको ये धक्का मारा, तो इसने इसको धक्का मारा. So this is going forward. So there will be some effect over here. Otherwise, all of them are going to remain in the same position as it is. Okay, they are going to remain in the same position as it is. Now what happens is, this particular thing is going to, what happened over here, this comes back to normal, because this is like this. It is going to go this way, then back to normal, and then backwards, then back to normal. Okay, this is what we are going to see over here. So front, middle, back, middle. So when it comes to the middle part again, so when it comes over here, at that time what would happen is that this particular part is moved forward because there is always a push. The push is not going to get end. It's not going to end over there. एक साइकिल को धक्का मारा तो वो साइकिल ने दूसरे को, फिर तीसरे को, चौथे को, ऐसे करके साइकिल धक्का मार ही रहा है ना एक दूसरे को. So that's why these particles are going to move forward, and there will be new particles over here which will be normal. So there will be something like this normal over here, a normal over here, a normal over here, but this particle has now moved, so they are going to come over here like this. 1, 2, 3, 4. तो ये part जो था, it is now traveled to this point. Okay, they are traveled to this point, and then the balance one are normal. So these are all the normal ones. Now the third condition is that it is going to go in the backward direction. So when it goes in the backward direction, it is something like a sucking action. Okay, अगर वो backward direction में अगर जाता है, so when this goes backwards, so it is going to cause a kind of a pulling action. So the particles will be pulled towards them. So when the particles are pulled towards them, so what happens is, these particles which are normal, they are going to be stretched towards them. Hence, it will going to be this way, that एक इधर आया, and they will be slightly further, slightly far away. ऐसे करके they are going to be separated by a further distance. So they are going to be separated by a further distance, and then will be the one which will be this particular part over here, which is going to be here. So 1, 2, 3, 4. So you can see that there was a compression, and this was an expansion or rarefaction. This is called as a compression. So this part over here is the compression, and this part over here is the rarefaction. Okay, it is C is compression and R is rarefaction. Rarefaction is the sucking action. So this is rarefaction. बाकी का आगे का part जो है वो normal रहेगा, तो it is going to remain as it is. And now it is going to be coming back to normal, that is this stage. So it is going to come to this stage. Now when it comes to this stage, at that time initially जो area जो है वहाँ पे थोड़ा normal हो जाएगा. So there will be normal over here, but so there will be some normal here, but this part has moved forward, so there will be this rarefaction which has moved now forward, and then there is this particular compression which has also moved forward. So this is going to be the compression, and then again there will be the normal part. So you can see that the rarefaction has now moved to this part, and the compression has now moved to this part. So you can see in this way, by the vibration, the sound traveled from one point to other point, then this point, then this point. So the sound is traveling. Okay, you can see this how the sound travels in air. So in air, the sound travels like this. Okay, it is going to travel like this. It is not going to travel like a wave like this. It is going to travel as a thing like this. So that is exactly what we are seeing over here, that there will be alternate compression rarefaction which is going to be formed. Now again, when this goes back, it is going to come back to this problem, this condition. So in this way, there will be continuous. The waveform what will be there will be like this, that it will be, we can say continuous. This is rarefaction, then compression, then again rarefaction, then again compression, then rarefaction. ऐसे करके the sound travels in air in the form of, this particular form is called as longitudinal waves. Okay, these are longitudinal waves, and they are formed of compressions and rarefaction. So in air or inside the liquid or inside the solid, the sound is going to travel by compressions and rarefactions called as longitudinal waves. Okay, so let's see what they have written over here. Exactly the same thing is what we have written here. So we'll just read that out. Example, take a vertical metal strip with its lower end fixed. That's this way. Lower end fixed, this is a vertical strip. Push its upper end to one side and then release it. So I put it to one end and release it. As it vibrates, that is moves alternately to the left, right, and left sound, left to left, sound is produced. Okay, that is the sound produced, but I cannot give you that particular sound on the mic, so you cannot hear that thing. No, you cannot. Okay, so that is sound is produced. Figure shows the steady or mean position of the metal strip and normal condition of air layers near the strip. So this is the normal condition of the air layers of the strip when it is not being pushed. As the strip moves to the right from A to B in figure, it pushes the particles of the air in front of it. So the particles of the air in this layer comes close and to each other, and that is air in that layer gets compressed, or compression is formed at C. So this is the condition where this is going to be C. So this is C, which is going to be formed. This is the C over here. So this is formed by the pushing or the compression which is done on the particles of the air. The particles of this layer will move, while moving towards the right, pushes and compresses the layer next to it, which then compresses the layer next to it, and so on. So ये compress करेगा इसको, फिर इसको. I told you about the cycle. Okay, it falls. So one falls, the other also falls, then other also falls. ऐसे करके it is just going to keep on forwarding it to the next layer. Thus, the disturbances moves forward in form of compression. The particles of the medium do not move with the compression. So, it is just that these particles, they have pushed this thing. Okay, the particles themselves are not moved. The particles are actually just pushing and coming back to normal. Okay, the particles are just pushing the next one and then other comes to normal. साइकिल में ऐसा नहीं होता, साइकिल में सब कुछ गिर जाता है, पर यहाँ पे क्या होता है, गिरने के बाद वो उड़ भी जाता है, because they are all elastic medium. Elastic medium मैंने क्या, गिरने के बाद खड़ा भी हो गया. Okay, like for example, when I took this one, it's a elastic medium. Why? Because when I put it, it is coming back to normal. Because it's coming back to normal, उसका मतलब क्या हुआ? It is going to be elastic. That is come back to original position. As the metal strip stops returning from B to A, after pushing the particles near the strip, the compression moves forward and the particles of the air near the strip returns back to the normal position due to the elasticity of the medium. That's what I told you, that due to the elasticity of the medium, the particles, this is pushed forward and there is this normal which is coming up because of the elasticity of the medium, and the compression has moved from here to here and then from here and then here and so on. When the strip moves to the left from the C, it pulls the layer of the air near to it towards it and thus produces a space of very low pressure on its right side. The air layer of the right side of the strip expands in this region, thus forming the rarefied layers. This region of low pressure is called as rarefaction R. So as this goes on the other side, this is going to pull the particles towards it. They are going to pull the particles towards it, and when it pulls it, the particles are going to move apart. So when they are moving apart, this is going to form a rarefaction. In this manner, as the strip moves to the right and left repeatedly, the compression and rarefaction region are produced one after the other. This which carry the disturbance along in it with a definite speed depending on the nature of the medium. So depending upon the nature of the medium, it is going to, when this vibrates, the compression and rarefaction is going to travel inside the medium from one point to another point. One complete to and fro motion of the strip forms one compression and one rarefaction. So I can say the one wave. What is one wave? This is one wave. One compression and one rarefaction. This complete part. So this complete set of this thing is called as one wave. Okay. This is one wave. That is one complete to and fro motion of the strip forms one. So this one from here, back here, here and back here. So this is the first position, mean position. A pe gaya, mean position. B pe gaya, mean position. This particular thing causes one particular full wave, that is one compression and one rarefaction. This wave in which the particles of the medium vibrate about their mean position in the direction of the propagation of sound is called as a longitudinal wave. So this particular kind of wave where it is traveling in the direction. So when the wave is traveling in the direction of the motion or direction of the direction of propagation of the sound, it is called as a longitudinal wave. This longitudinal wave can be produced in solid, in liquid as well as in gases. So longitudinal waves are present in all the three, that is solids, liquids and gases. But inside, okay, it is going to be inside the solid, inside the liquid and inside the gases, not on the surface. On the surface, it travels by another kind of thing which is called a transverse view. So right now you understand it just the part that when it is one single movement, that is it's a longitudinal wave which is inside the solid or inside the liquid or inside the gas. Thus, due to propagation of wave in the medium, the particles of the medium vibrate about their mean position without leaving their position. So what has happened is that this particular thing, why is this formed? Because there is a vibration caused over here which brings them together. Basically, vibrations are caused over here which brings them apart. So it is the vibration of the particles which is causing this movement of the medium. Thus, due to propagation of the wave in the medium, the particles of the medium vibrate about their mean position without leaving the position, and they transfer the energy with a constant speed from one place of medium to another place. So that was about the longitudinal waves. Now we need to understand certain terms which are used in waves. Whenever we have any particular wave, we will have a particular terms which are going to be used. So for that, what we'll do is that instead of taking this particular kind of wave, let us take a waveform which is like a transverse wave. So it's easier to understand also. So when we see a wave, it is going to be this way. The waves are going to travel like this. Okay. So in this case, the first thing what we are having is this particular distance is A. Now A is amplitude. Okay. So the maximum displacement of the particle of a medium on either side of the mean position. So from here it moved upwards also that much and downwards also that much. So that particular maximum distance what the particle is going to be moving, the maximum distance which a particle is going to travel, or displacement of the particle in the medium is called as from its mean position is called as the amplitude. So the maximum displacement of the particle of the medium on either side of the mean position is called as its amplitude. So here also I can say from here when it is traveling to this point. So यहाँ से लेकर यहाँ का जो distance था from this point to this point we need traveled here. So ये जो distance जो है, that is the displacement between this and this point over here, is called as the amplitude of the wave. It is denoted by the letter A and the SI unit is meter. Because of the displacement it will be measured in meters. So that will be SI unit meters. The second is time period. The time taken by the particle of medium to complete one vibration is called as the time period of the wave. It is denoted by the letter T and SI unit is second. So the time taken for this one particular wave to take place. So this particular time taken for this particular wave, that is this much time. So this is the time period T. Okay. Third is frequency. Now this is not going to be such that he 1 second में इतना ही घूमेगा, 1 second में बहुत सारे होते हैं. So the number of waves per second is called as the frequency. So the next was time period, and the fourth one is frequency. Now frequency is nothing but the number of vibration produced by a particle of a medium in 1 second is called as the frequency of the wave. It is also defined as the number of waves passing through a point in 1 second. It is denoted by the letter F. The SI unit is so here the SI unit is meters, here the SI unit is second, here it is second raised to minus 1, or it is hertz, HZ, it's hertz. Second raised to minus 1 or hertz. The frequency of a wave is equal to the frequency of the vibration of its source. Of course, the frequency of the wave जो भी रहेगा, it will depend upon the frequency at which this is vibrating. If this is vibrating at a frequency of, let's say, 10 in 1 second, then it is automatically the frequency of the wave also will be 10 per second. That is 10 hertz. It is characteristics of its source which produces the sound. It does not depend on the amplitude of the vibration or on the nature of the medium through which the wave propagates. So it is seen that the frequency is not dependent on the amplitude, neither is dependent on the medium कि वो पानी में है या air में है या solid में है. It doesn't depend on that. It is only dependent on the source of vibration. कितना source vibrate हो रहा है उसी हिसाब से waveform का frequency is going to be determined. So the frequency of the waveform is going to depend only upon the source of the vibrationing body. It is not dependent on the amplitude कि ये कितना ऊपर गया, because there could be a wave which could be also like this. Okay, it could be also like this. So then the amplitude is higher, but that doesn't make the frequency anytime higher or lower. So it does not depend on the amplitude of vibration or on the nature of medium through which the wave propagates. So relationship between the time period t and the frequency, if t is the time period of the wave, then by definition in time t the number of waves is 1. Therefore in 1 second number of waves will be f is equals to 1 upon t. So we have over here that we said that what is time period? Time period is time taken for one wave. Okay, so time taken for one wave, the time taken is t seconds. And the frequency over here, what is the frequency? That the number of waves, the f waves in 1 second. Okay, so you can see over here that f is equals to 1 upon t, because if the time taken for one, see it's a simple thing, 1 second में इतना तो frequency, what is the frequency? Frequency is 1 upon the time taken for 1 second. 1 second में कितने waves होंगे? If one wave is taking 0.2 seconds, then in 1 second how many waves will be there? So it will be 1 upon 0.2, so the frequency will be 5. Understood? So this way you have that in 1 second the number of waves will be f is equal to 1 upon t, thus frequency is 1 upon time period, and time period is equal to 1 upon frequency. So that is, or you can also write time period is equal to 1 upon frequency. Both these are the relationship of frequency with the time period. The fourth thing over here is the wavelength. The wavelength is from this point to this point. This is the wavelength. So that is given by a letter called as lambda. Okay, there is a letter called as lambda. It is lambda, lambda. Okay, that is nothing but the wavelength. It is also measured in meters. So the distance traveled by the wave in one time period of vibration of particles of the medium is called as wavelength. It is denoted by the letter lambda. SI unit is meters. It depends on the nature of the medium through which the wave travels. So here this wavelength will depend upon the nature of the medium through which it's traveling, whether it is going to be bigger or smaller. जो भी है wavelength जो है, it will depend upon the medium. So in a longitudinal wave, the distance between two consecutive compressions and between two consecutive rarefaction is equal to the one wavelength. So between two consecutive, so if I got a wave like this, so these are the rarefactions and these are the compressions, then again a rarefaction and again a compression. So the distance between this and this is nothing but the lambda, which is distance between two consecutive compressions or two consecutive rarefactions is called as the one wavelength. Okay, so this was about the wavelength. We'll continue then about representation of the wave in the next video.